Hello, we are here with Professor Andreas Georgopoulos from National Technical University of Athens, a very good friend of ours who happens to have his birthday today. So, happy birthday, Andreas.
Thank you very much.
It was very nice having you here.
Thank you.
And the privilege to hear what you had to say.
The privilege was all mine.
About automation in the processes that we're using to digitize the world and, most importantly, cultural heritage. So, what was the idea behind that problematic?
We have experienced a rapid intrusion of automation in our disciplines, and especially in cultural heritage and the production of 3D artifacts. So one wonders whether this rapid development is worth accepting or should be met with caution or not. So we thought in our lab to try to test these automatic algorithms, which are realized by some commercial software, of course, and some, open source software, but we have established that they more or less perform the same. So what we did was to test one of these software and see whether it's worth trusting it or not, because it has become very, very popular.
So I suppose when you talk about testing, you have to have something like a prototype.
Yes, being a surveyor, a land surveyor, and a photogrammetrist, we always think about metric quality, how well we measure, And this was the main aim of our test, how well the 3D result, the 3D reconstruction is, how accurate it is coming from this software. So we had a test field in our lab, which we use for various purposes, camera calibration, etc., and we use that as an object. The points are very well measured, geodetically to 0.1 of a millimeter.
It was something like a field of poles.
It was, yes, a lot of, like a forest of poles, yes, with the points on there, pre-marked points, and a board at the back. So there are many points that we could use as either ground control points to connect what the software produces to the real world, and reserve some of the points as checkpoints and see how well they were determined by the software.
So these points are fixed to a very well-known position, I suppose.
Yes, we have measured them geodetically to 0.1 of a millimeter in a local coordinate system, and everything was performed in this local coordinate system.
So what did you actually set up there to test?
We had two cameras to test. One very sophisticated DSLR, a full frame, a very well-known camera with two fixed lenses, a wide angle and a normal one. And we have tested this camera to a lot of previous projects, and we know that it performs very well, geometrically. And radiometrically, of course.
Yes, of course.
And we also had a compact camera, a very cheap, simple camera. A typical compact camera, yes, which doesn't have the specifications of this DSLR.
Were those cameras of similar resolution?
No, definitely no. Definitely no.
Okay.
The compact camera was a very low resolution and a very small pixel pitch, 1.4 microns, which is nothing, and the other, the DSLR had a 6.4 microns, which was
huge difference.
Huge difference, yes, a huge difference. And we took some pictures as if we had to reconstruct in 3D this object, this test field. The bundle adjustment, we did it with some GCPs, some 16 GCPs, and we tested the result on those GCPs and on another 14 independent points that were not used into the adjustment. And the results were quite interesting. We expected that the DSLR would give very good results, as it did. But also we had some very good results from the compact camera. So yes.
Very interesting.
Okay, I don't say that take your compact cameras
Yes.
and go out and measure, but
Yeah, this is very interesting because
It
this,
is, it
this
is interesting,
opens
yes.
up, you know, the field for many
Yes,
people. In
yes. I think it's the algorithms that
algorithm, yes.
help the deficit or the not very good images to perform well, because you have a lot of redundancy. You have a lot of images and a lot of rays that converge to the same point. So there is a lot of redundancy in the adjustment, and this compensates for the low resolution and the low quality.
So after taking the photos, you actually applied SFM? Was that the method?
Yes, we apply SFM to determine the camera position, and then there is a dense image matching
Dense
algorithm,
image matching.
and then there is a together with a bundle adjustment and the surface reconstruction, and we measure on the final result. We measure on the final result.
So, to automate or not?
I would say yes,
Yes.
but with caution. Be careful and take care of the parameters in the software, take care of how you take the pictures, take care of the illumination, I mean all the photographic conditions, the metric conditions, everything should be taken care of, and one should know what one is doing, yeah. Not just take some pictures, put them into the software and have a
And
coffee.
wait for
no,
the,
no, no,
wait
this
for the
is,
results.
this is
Yes.
danger. Yeah.
Yes, this is dangerous. Okay, okay. Thank you very much, Andrea.
Thank you, George.
Happy
Thank you very
birthday
much.
again.
Thank you very much.
Nice
Thank
to have you
Yeah.
here. I hope to have you here again.
I hope to be able to come. Yeah.
Thank you. Thank you.
And
Thank
please
you.
don't make it on the 26th of September.
Thank you.